Imagine tossing a message in a bottle into the cosmic ocean. For nearly 50 years, that's what Voyager 1 has been for us, humanity's lonely messenger to the stars. But as it finally tried to leave our solar system, it sent back a shocking message. It had hit a barrier, what some have called an invisible wall of fire, a region of superheated plasma where particle energies correspond to temperatures of tens of thousands of degrees. This is the incredible story of its journey and the discovery of a fiery frontier that separates us from the great interstellar void. Launched in 1977, Voyager 1 wasn't originally destined for the stars. It was built for a grand tour, a rare planetary alignment that happens only once every 175 years. Its job was to visit Jupiter and Saturn, and what it found completely changed our view of the outer solar system. It showed us Jupiter's faint, hidden rings and discovered active volcanoes spitting sulfur on its moon, Io. Then at Saturn, it delivered breathtaking images of the iconic ring system and its complicated family of moons. After acing its primary mission, Voyager 1's journey took a profound turn. In 1990, at the request of astronomer Carl Sagan, it turned its camera back toward home and took one of the most important photographs in history, the pale blue dot. From billions of miles away, our entire world was just a tiny, fragile speck hanging in a sunbeam. That picture marked the end of Voyager's planetary tour and the start of its next chapter. A long, quiet trip toward the space between the stars. For decades, it sailed through the dark, its instruments patiently measuring the sun's fading influence. To really get what Voyager discovered, you have to understand where it was going. Our solar system sits inside a giant protective bubble called the Heliosphere, which is constantly inflated by the solar wind, a stream of charged particles pouring from the sun. The heliosphere is our shield, protecting the planets from the harsh radiation of deep space. But this bubble doesn't go on forever. Far beyond Pluto's orbit, the solar wind runs out of steam, unable to push back against the gas and dust that fills the space between stars, known as the interstellar medium. The boundary where these two forces clash is the heliopause. For years, scientists could only guess what this frontier would be like. Voyager 1 was our first real chance to find out. On August 25, 2012, its instruments logged a sudden, steep drop in solar particles and a huge spike in galactic cosmic rays. The message was unmistakable. Voyager 1 had become the first thing humanity ever sent into interstellar space. But the boundary was far stranger than anyone expected. As it crossed the heliopause, Voyager 1 found itself in a region of shockingly intense energy. This has been dubbed the Wall of Fire in some media reports, a shorthand for a narrow shell of plasma with particle energies that translate to temperatures between 30,000 and 50,000 Kelvin. Now, this isn't fire like a campfire. The plasma is incredibly thin, way less dense than the best vacuums we can create on Earth. So the spacecraft didn't burn up. An astronaut would freeze instantly, but the particles themselves are fantastically energetic. The leading theory is that when the fast-moving solar wind crashes into the slower, denser interstellar medium, it creates intense compression and magnetic chaos that supercharges the particles. What's wild is that scientists figured this out with some clever detective work because Voyager 1's main plasma detector actually failed back in 1980. When a massive solar flare sent a shockwave blasting through space, it made the plasma around Voyager literally vibrate, or ring, allowing the plasma wave subsystem to measure its density. That density was a stunning 80 times higher than inside the heliosphere, proving it was in a totally new environment. Years later, in November 2018, its twin, Voyager 2, crossed the heliopause at a different spot. With its own plasma instrument still working, it confirmed the sharp jump in both plasma density and temperature. Showing this fiery barrier is a real and persistent feature of our solar system's edge. And to add another twist, Voyager 2 confirmed that the sun's magnetic field lines up almost perfectly with the interstellar magnetic field, defying models that predicted a dramatic shift. Discoveries like these are exactly why space exploration keeps us on the edge of our seats. If you're as fascinated by the mysteries of our universe and the incredible journeys we take to solve them as we are, Make sure to subscribe and join our community of explorers. As of 2025, nearly 50 years after it launched, Voyager 1 is more than 15.5 billion miles away. It's so far out that a signal from Earth traveling at the speed of light takes about 23 hours to reach it. Its nuclear power source is fading, and NASA engineers are carefully shutting down systems to keep it alive. Voyager 1's cosmic ray detector was turned off in early 2025, and Voyager 2's plasma science instrument was powered down in late 2024 to conserve energy. Soon, all its scientific instruments will go silent forever. But its journey won't end. It will drift silently through the Milky Way for millions of years, carrying its golden record, a time capsule of sounds and images from Earth. This lonely probe, built for a mission that was supposed to last just a few years, didn't just redefine our solar system. It pierced its very edge and revealed a violent, energetic frontier that we never knew existed. It remains a testament to human curiosity, our farthest messenger in the vast cosmic dark.